So next question, when Q is equals to 100, so we need to find the minimum average cost. So what we do is to substitute Q equals to 100 into the average cost function. So substitute into average cost function, we should get 1 here plus 5 plus 100 divided by 100 equals to 1. Therefore the answer is equals to 7. Alright. Okay, next we move on to revenue, average revenue and marginal revenue function. So we have some important formula. Formula A we have done earlier, where the revenue function is given by P times Q, where P is the selling price per unit. Okay. Then next, the average revenue is given by revenue divided by quantity, or R over Q. And finally we have marginal revenue. So marginal revenue is given by dr over dq. Okay, let's look at example 9. In example 9, the demand function of product is given by P equals to negative 200 Q plus 500. So we are asked to find the revenue function. Second question, find the marginal revenue function. So part A, revenue function is given by P times Q. So substitute P with negative 200 Q plus 500 into this function. So we will get negative 200 Q square plus 500 Q. Okay. So part B, we are asked to find marginal revenue. So marginal revenue is given by dr over dq. So what we do is, we take from part A, we differentiate negative 200 Q square. So we will get negative 400 Q. And then differentiate 500 Q, we will get 500 here. Okay? Okay, how to maximize revenue? Alright, in business definitely we need to minimize cost and maximize the revenue in order to get maximum profit. Okay? So in order to maximize the profit, there are two steps. Steps number 1, we need to find the stationary point, which is dr dq equals 0. Then the second step is to find d2r dq square and determine whether the answer is positive or negative. Remember, positive means minimum, negative means maximum. Alright? Okay, so if d2r over dq square is less than 0, which is negative, then the revenue is said to be maximum. Okay, so let's look at example 10. In example 10, the demand equation of a product is given by P equals to AT minus Q over 4. So we are asked to find the quantity required to maximize the revenue, part A. And then part B, we are asked to find the price that maximizes the revenue. So we start off with the revenue function, which is P times Q. So substitute P with AT minus Q over 4 times Q. So from here, AT divided by 4 is 20, 20 times Q will be 20Q. Negative Q over 4 times Q will give us negative Q square over 4. So this is the revenue function. But we are asked to find the quantity which will maximize the revenue. So what we need to do is, remember the two steps. First step is to find dr dq, and second step is to find d2 square r over dq square. Alright, so dr dq, when we differentiate this, 20q will give us 20, differentiate q square, we will get, bring down the 2, so 2 divided by 4, 2 and 4 cancel, remainder 2. So we have 20 minus q over 2 equals to 0 to find the stationary point. Okay, so we will notice that the value of q is equals to 40. So the second step is to find d2r dq square, and from dr dq just now, when we differentiate, the answer obtained will be negative half. So negative means maximum, alright? So therefore, we say the revenue is maximum, and the value of q that maximizes this revenue is 40, alright? So in part B, when q is equals to 40, remember we are asked to find the price, maximum price that maximizes the revenue. So this happens when q is equals to 40, right? Q is equals to 40. So substitute into the price function, we'll get 80 minus 40 divided by 4. Therefore the answer is equals to 10. Okay, so hence the price that maximizes revenue is 10 ringgit. Okay.